So now that we've looked at the various rules of trigonometry, it's time that we look at trigonometry applied in the real world. And we'll do that by looking at vectors. So let's start by defining a vector. A vector is just something with a magnitude and a direction. And if that seems confusing, just bear with me, and hopefully by the end of this video, it will make perfect sense to you. So let's go from there and define magnitude. Let me pick a different color here. And magnitude is just an amount of something. Just an amount of something. And it could be anything. It could be speed, it could be weight, it could be distance. The magnitude is just the amount of whatever it is you are measuring. And hopefully I don't need to define the word direction to you. Hopefully you know what direction means. But a vector is something with a magnitude and a direction. So real quick, let's look at some examples of not vectors and vectors. So let's make ourselves a little table here. And let's say on one side, not a vector. And let me pick a good color. We'll call this side not vectors. And we'll call the other side vectors. So a good example of something with a magnitude that's not a vector would be something like saying that you're traveling 60 miles per hour. You're telling me the magnitude, but you're not telling me the direction. So a vector would be 60 miles per hour north, for example. North. So another example of not a vector, if I say I move a table. Move a table. Maybe I move it to the right. That wouldn't be a vector because they didn't tell me a magnitude. But if I say I move a table, let's say 5 feet to the right. Let's just draw an arrow for right. Well, this would be a vector because you gave me the magnitude and the direction. What if I'm talking about weight? Well, weight, if I say something weighs 80 pounds. That would be a vector because weight is downward. We already know that that's a downward force. We already know the direction, and you just told me the magnitude. But if you said throw a ball with 80 pounds of force, throw a ball with 80 pounds of force, we don't know what direction it's going, so it's not a vector. So any one of these could be an example of a vector, and there's countless more types. But today we're going to keep it simple. Today we're going to talk about just vector displacement. And all displacement is just a net movement. And let me make this a little bit wider so it stays in the same line. Net movement. That's all it is. How far did something move? Now before we look at an example of vector displacement, let's go ahead and look at this word direction. Now there are two ways to look at direction. There's a sense of direction, which is more of a general definition of direction. And then there is, let me pick a good color here. Here's a good color. There's the more exact one, and that's the angle. The angle would be the exact direction. The sense would be sort of just a general. Let me explain what I mean. Hopefully by now you know what an angle is. Let me go ahead and explain what I mean when I talk about a sense of direction. So if I were to draw just a quick graph here, and let me get my pencil tool out and call this, of course, this is the y direction, and this is the x-axis. Okay. And we were to start with some random direction. Well, this would have a sense. Let me label sense in blue. Keep our colors consistent. But a sense, these are our senses. This would have a sense of a positive x direction and a positive y direction. Or another way to look at that is up. Well, this way is up and to the right. And that's all a sense is, and we can do sort of all 4 types of directions. Well, there's more than 4, but the 4 main ones. Not including completely horizontal, completely vertical. But now we're going down and to the right, so that's a, still positive x, because it's still going to the right, but now it's a negative y. We can try a different color. We can go this way, and now it's negative x and a negative y, and then we could do one more. We could say we're going this way, and that would be a positive x, or well, no, that's a positive y, and a negative x. And that's essentially what a sense of direction is. Just which way is it going. But with that, let's go ahead and look at an example of a vector. So let's draw an x and y axis here. So we got our y, and we got our x. Let me go ahead and get my pencil out. We'll call this the y direction and the x direction over here. And let me go ahead and label these with numbers. So we'll say 1, 2, 3, 4, 5, and I'll go to 7. And let's say we have some object. And this object starts at, I don't know, how about 2, 1? Let's say it winds up at, I don't know, 5, 5. Let's say it ends up there. So it starts here and ends up there. And so it was moved a certain magnitude. It moved a certain amount. And since it has a magnitude, we just don't know what it is, and a direction, this is a vector. We will call it vector, well, it doesn't really matter what we call it, so I'll just name it vector n. So I have a few questions for you about vector n. My first question is, what is its sense? My next question is, what is its magnitude? Let me start off spelling that correctly. What is its magnitude? And my last question is, what is its direction? What is its direction? And of course, this direction would of course be, in other words, what is its angle? Equals question mark. Well, hopefully its sense is too easy and too obvious. It should be incredibly easy. It's going up and to the right. And of course, up and to the right, those are just two fancy words for positive y and positive x. The next question asks, what is its magnitude? And let's go ahead and name this something. We said how many ticks it were, but let's go ahead and name these ticks. Let's say each one is a foot. So it's feet. So it's 1 foot, 2 feet, 3 feet. But in this case, this vector is a displacement. It's moving a certain amount of feet. And our job is to find out how much. We can't really count the squares this direction because it's sort of in a diagonal way. But if you notice, the squares actually make a triangle. So we have our in the x direction. And I'll go ahead and label this as such. I'll call it in the x direction, or n of x. And it also goes in the y direction. So I'll call that in the y direction. And it is a triangle, so we have an x component, which is just in the x direction, which is just what? 1, 2, 3. And then we have a y component, which is just in the y direction, our vector in the y direction, which is just 4. So essentially this question just becomes a regular triangle question. What is the third side, which is the hypotenuse, or c squared? We can use our old favorite formula, Pythagorean theorem, a squared plus b squared equals c squared. So we've got 3 squared plus, pick the right color here, plus 4 squared equals our vector in c squared. Let's go ahead and write that out. Actually, instead of saying c squared, we'll say vector n squared. Well, this becomes, well, 9 plus 16 equals whatever vector n squared is. Well, that's just going to equal, we can just say that equals 25. So 25 equals n squared. Okay. Well, that means vector n is just the square root of that, which is 5. So the magnitude is 5.
And we'll go ahead and solve for the angle in the next video.